now it looks the unmanned hour makes sense to me. Now let's look at the hourly data for the each equipment. So let's turn off the simulation first. So let's look at the system one by one, what we can get from the output variables. So we can hold the shift, press the shift, and connect to the output parameter to the coil. It seems there's nothing we can get from the coil. Okay, let's hold the control and then hold the shift again to connect to the baseboard. So from the baseboard, we have the output variables. Okay, let's try to we can get a separate convective heating and the radiant heating energy rate. Let's get a total heating rate and set Boolean toggle to true. Okay, and the pump, let's see, pump, we can get pump electricity energy, electricity rate, mass flow rate. Which is water flow rate for every hour through this pump. And for the boiler, let's say we can get the natural gas rate, because that's a default fuel type we are using for this boiler. So the fuel type is natural gas. We can, let's see what else we can get from here. Our boiler heating rate. That basically tells you how much heating is generating from this boiler. Okay, I guess that we have, let's see, this is a boiler heating rate. We need a copy, right click and copy data only, and then paste into a new panel and convert it to a multi-line data. So you can see this one is one single data here, but here we have, say, 1, 2, 3. Let's remove this empty one. So we have 2 entries. And same thing goes to the output variable for the pumps. Copy. Let's just paste it inside this output panel and this one as well. No, here. Baseboard totally. Alright. We are going to request the output from the SQL file. And let's run again. So by checking this hourly output rate, heating rate, we can calculate what's the efficiency of the entire system from the input natural gas to the output heating rate from the baseboard. Now let's look at the output result. So unmanned hour is all fine. We have checked. So this is a cooling unmanned hour. it's fine because we don't have a cooling system. So this one is the baseboard total heating rate for each zone. You can see for this first zone, the peak hour, it uses close to 6 kilowatt during some hour, probably it's here. And for the second zone is is close to 4 kilowatt. So this one is using 6 kilowatt, around 3.8 kilowatt, all the way to the last zone of the baseboard. And this one is the boiler's heating rate. So how much heating energy the boiler is generating. It's generating the maximum heating rate is 42 or 43 kilowatt. And this guy is the natural gas rate. So you can see for the boiler itself, let's do the math. Calculate. So this is roughly 42.8 divided by 53.5. So 0.8. So this exactly matches our input here. The efficiency of the boiler is 0.8. You can see here this matches. It makes sense. And what's the next? The pump electricity rate. So and the pump flow, mass flow rate. So how much water is going through this pump. So if you check the pattern here, this means whenever the value is 0, that means pump is running, and that's hot water going through the boiler as well. So this pattern, you can check the schedule pattern. They are all matching together. That makes sense. Okay. Now let's look at the hourly data. Let's try to get what we need to get the initial natural gas rate. So let me copy. Going to multiple lines. Well, we already checked the efficiency of the boiler is 80% from the heating rate and the natural gas rate. So we don't need the heating rate anymore. We don't need the electricity mass flow rate. Baseboard, okay. All we need is 3 values. Okay, let me lock the server and copy paste the SQL file. Let's only request this 3 set of the data. So we have hourly data. We can deconstruct this data by using Honeybee. LB deconstruct data. Okay, you can get the headers and all A760 zeros, A760 values. Okay, let's assume probably they are all happens at the same hour. Let's assume all those peak hour happens the same hour across all this data. So we just only get the maximum. Let's do bound. It gives you a range of each set of data. And where is the bound? this guy, and we can get the deconstruct domain to get the maximum value. And get the headers. So the first 8 the first 8 is the baseboard heating rate of each zone. We can separate. We can do the data structure here to get the total heating rate from the baseboard. But now let's just, for some beginners, it's easier to do like this. Just separate the output. In this case, we remove the base. Oops. Now let's copy this guy and lock the server. Paste. And now we can get a total. Oh, a long input SQL file. All right, and then we can do flatten and mass addition. Mass addition, it gives you a total value. So this one is baseboard heating. Heating rate. Peak, at the peak. So it's watt. And this guy, one is the natural gas rate, one is the electricity rate. So those are our input. Energy from the system. That's a total value. So boiler input. So it can be, let's say, is boiler plus pump watt. So now if we just simply do the math, we can get the overall efficiency of this system, which is close 74% of the overall system. Now let's look at what we can improve for this system. So I have checked the energy plus input output reference, the boiler hot water documents here. So here's the example to show you a more efficient condensing boiler. This one has 89 efficiency and also has a more accurate performance curve. So we are going to replicate this boiler in our simulation. Let me just, I just copied. I'm going to paste them here so that I don't have to go back and forth between windows. Okay. Now let me close and turn off the simulation. For the boiler itself, it's using the natural gas. The name we can say condensing boiler. The fuel is natural gas, so it's already natural gas. So capacity, yeah, we can hard size it. Nominal capacity, I don't know if it's enough because we need close 84 or 40. Previously, we at the peak hour, it needs at least 43 kilowatt, and this one is 25 kilowatt. So for capacity, we're just using auto size. So we're not going to hard size this one. Efficiency curve variable, evaluation variable. The efficiency curve temperature evaluation variable is entering boiler, okay, and normal efficiency 0.89. Capacity, we're not going to hard size the capacity. And efficiency curve is this guy. Biquadratic. So curve biquadratic. So I'm going to copy this coefficient. Right click, change it to multi-line data. Remove this documentation. Okay. And the parameter for this curve as well. So the max x, this one is a minimum of x, minimum of y is 30, maximum x 1, y maybe 5. Okay, efficiency curve, temperature 80, on cycle electricity load. Okay, I guess this optimal partial ratio, load ratio, optimal power load ratio 1:1. Okay, this one is 25 watt. Okay, sizing factor, doesn't mention. I think it's fine. All right, now we have all the values matching our boiler. Let's run a quick test again. Now we are getting slightly lower heating energy for the EOI. This, I believe, remember previously it was like 9, what's the unit? 9 kilowatt hour per square meter. Now it's 8, so which is good. Now, if you look at the overall efficiency, you can see it was like 73, 74. Now it's 85%. The overall efficiency of the system. All right, let's check the ambient hour. It's still good. It's all fine, I believe. Okay. All right, now we have a very simple hydraulic or heating system finished inside the grasshopper. So of course, this is because this is a tutorial. I'm going to show. I was trying to show you every step of this workflow, and you can just try to find. You can also find this kind of similar system from the template HVAC template. There's one from the reading ceiling. So this will be a little bit more complex than the current baseboard system heating system. Is because you need to set the construction for the ceiling in order to run this type of a system. And here is how system is set up. You can double click, so you can see it's more complex system. It also has a cooling system inside as well. So because reading ceiling also does a cooling part as well. So this is a hot water loop, and it also includes the ventilation, which we will cover in the next tutorial. All right. All right, that's it for this tutorial, and bye. See you in the next one.